All right, test, test, test. Can you guys hear me all right out there? All right. Okay, so my name is Coogan. I work for Consensus. We are a Web3 technology company that is primarily associated with Ethereum, but we do a lot of different projects in the space. I am here tasked today to teach you about blockchain, just to make sure that we're all on the same page before you guys start seeing these really wonderful presentations about use cases and the future and all these sorts of things. One of the things that I do at Consensus is make sure that everybody understands some of the foundational ideas behind blockchain. Because obviously there's a lot of excitement, there's a lot of hype in the world around blockchain, but when you actually sit down and ask somebody, what is blockchain? Or do you have a wallet? Or have you ever, bought a cryptocurrency? Very few people actually have. And so it's really exciting to be able to bring to people the actual fundamentals of blockchain. So that's what today is going to be. It's going to be about 45 minutes. I'm going to talk a little bit about Consensus. I'm going to talk about the context from which blockchain arose. And then we're going to sort of dive into some of what I sort of call the crypto primitives or some of the blockchain primitives that underpin Ethereum, but ultimately underpin any blockchain network to a degree. Now, I'm sure there are a lot of very smart people, and I'm going to be making a lot of generalizations, but it's all for the sake of the greater good. So, before we start, just to get a sense of how many people before seeing this conference had heard of blockchain technology? Raise your hands. All right, that's probably good. If you're at a blockchain conference, you probably should have heard of blockchain. Okay, how about who has heard of Bitcoin? Yeah, about the same. Who knows somebody who has bought or held Bitcoin or used Bitcoin? This is great. This is great. We got some real crypto heads in the audience. How about Ethereum? Anybody familiar with Ethereum? Very cool. How about Hyperledger? Does anybody know Hyperledger? Oh man, got a good crowd here. How about Libra? Does anybody know about Libra? Alrighty, cool. Great, so this is obviously a really, an audience that kind of knows the landscape for the most part. So what I'm hoping to do here is to be able to talk a little bit about again, just those fundamentals. And if people want to sort of call out questions, since people are very familiar, we're going to have time for questions at the end. But if something really is like kind of itching at you, I think it's a small enough crowd and a well enough established crowd that you guys can just holler out. We can be rowdy. We can be rowdy here. Okay, this is me. I'm a technical trainer at Consensus Academy. I got my start working on the Go Ethereum code base, which is the Ethereum client put out by the Ethereum Foundation. And been involved in blockchain since about 2011. I was just talking with Kevin here about our similar starting points around bookstores. And I also want to say it's really exciting for me to be here at UT because I am part of a Longhorn family. My wife works at UT Austin doing development, and I have actually guest lectured here a number of times at the School of Information for Lance Hayden and his blockchain course. So it's really exciting to be here. Really, really grateful that Texas Blockchain invited me to come in. It's really exciting. Alrighty, so Consensus, I'm sure a lot of you are fairly familiar. Global formation of technologists and entrepreneurs building infrastructure applications for Web3. We are predominantly based around Ethereum, but we have all different sorts of arms. Grid Plus, Carl Crater, who's going to be presenting here later today, that was initially under the guise of Consensus. If anyone has used MetaMask, that is a Consensus product. And if anybody has used the Truffle framework, that is also a Consensus product. We also just announced that we have a product that is now being associated with Hyperledger. So we're part of the Hyperledger family as well in terms of we created the first public Ethereum mainnet client for Hyperledger. That was just announced over the past week or so. I work for Academy, and so we are the educational core of blockchain. It's sort of a big role to fill because There is a lot of stuff to teach about. We teach about 101 stuff like I'm going to be doing today, but we also teach predominantly to developers online who are coming from the Web 2 world or maybe very familiar with JavaScript or familiar with Java, and they want to know what's the equivalent in the Web 3 world. They want to say, okay, I know what events look like, and I know what promises look like in JavaScript. What does that look like in Web 3? And so we're able to take them through these courses and these steps to teach them that. We also are brought in to teach sort of executive level trainings as well. So these are executives who want to say, I run a foundation, I run a nonprofit, and I want to understand what the application is for my company. And then last, we teach sort of cutting edge theoreticals. So this is zero knowledge proofs, meta transactions, kind of the more out there things, Ethereum 2.0 concepts. These are the kind of things that we're trying to sort of establish the boundaries of. As soon as the specifications get firmed up, we kind of start immediately working on educational material. So it's a really exciting thing because I get to work with a lot of the core developers in the blockchain ecosystem and then immediately turn around and try to explain that material to groups like this and sort of spread the word. So yeah, this is what we're going to go over today. We're going to skip this last Ethereum platform that I'm really going to talk about. We're going to talk about key applications. But first, this is our essentials class that we teach. This is not going to be going into a lot of technicals, but this will. If you guys want to go to learn.consensus.net, that's that. And then we also have this developer bootcamp, which is a 6-week bootcamp, which takes people from Web 2 to Web 3 in about 6 weeks. All right. So we're going to start. One of the things that I really like about teaching blockchain is that it actually requires people to fundamentally understand things that they take for granted in their everyday life. For example, if you take out $1, people say, well, this is $1, but blockchain is just making money out of nothing. And it's always really fun to sort of be like, well, actually, that dollar is nothing in the sense. Like, that dollar is given its value from the value that we as a society give it. I was just talking with someone about how we left the gold standard in the 70s, and so that's actually not affiliated with anything. And so it's really fun to be able to challenge people's assumptions about what they think are very clear about the world and sort of fuzz it a little bit and then sort of use that as an introduction to blockchain. So we're going to do that a little bit. It's going to seem like it's a really basic example I'm walking through, but it's really important just so we're all on the same page. Okay, so imagine this is, let's see, this is me, I don't know. This is me, I'm at the farmer's market, I want to buy a carrot from my friend the farmer. So I show up and I've got my credit card or debit card and I try to pay for this. And what's going to happen here is that this debit card is representing a sort of a ring back to this central institution, right, this bank. And what this farmer is going to be doing is he's going to be saying, asking the bank, does this person have the money that I need to give them this food? And the bank says, yes, this person does have the money, and says, okay, great, here's a carrot. Perfect. That's in finance. It also works in terms of identification, in terms of government, right? Let's say I get on my way over, UT police says you're not allowed to park here, let me see some ID, young man, and I say, all right, here you go, here's my ID. Now that ID is going to be issued by another centralized institution, right? It's going to be issued by a government, either national or local, and then that police officer is going to be able to check a database that is also affiliated with that institution. It's going to be able to say, okay, you're fine, go on to the blockchain conference. So my question for you is, what values does this centralized institution represent to our society? Like, why do we allow it to back to back a lot of the fundamental transactions that we have in our society? You can just sort of shout it out, any sort of thing. Trust, yeah, exactly. We are all agreed, we've agreed that we'll trust a sort of a third party. We'll say, I don't really trust you, but I trust this third party. It's absolutely right. Any other values people can think of? Yes, great, perfect, security. We're hoping that this institution will keep our information secure, right? Well, the reason why we're giving it to a bank or the reason why we're giving it to a government is so that it stays nice and protected, that it can't be accessed by other people. And then sort of the last one that I say sometimes is accessibility. Like, you know where to go if you need to withdraw money, or if there's a breach or that sort of thing. So here we go. We've got these. Trust security. My friend right here in the front row did it great. So all these values are incorporated into these different relationships that we have with these people, right? Like those are the things. So what is blockchain and why are people so excited about it? Okay, blockchain is saying, what if instead of a centralized institution, we could develop a protocol, a computer program that would embody all those values that we instinctually put into this centralized body. And what's interesting about blockchain is that the technology has actually been around for quite a good number of decades, right? So why is it actually happening now? Well, on the blockchain developer perspective, the 2008 financial crisis is typically cited as the motivating force for Satoshi Nakamoto to publish the Bitcoin white paper and sort of effectively create Nakamoto consensus and create Bitcoin and blockchain as we know it. There's sort of, it's very unclear, but it seems that the financial dealings around that time had really caused a lot of consternation in the community. People were sort of questioning kind of what is to be done about the financial system. So that stimulated a lot of development on the developer side. However, people have been sort of questioning those for a long period of time. The thing that I'm most interested in is why has there been a public adoption? Why are you guys in this auditorium today at this great institution, in this really great engineering building? Why are we talking about it now? And I would suggest that it's because there have been a number of data breaches in the past few years, financial crisis, all these different sorts of things that have sort of caused us to say, hey, we initially thought we were putting trust, security, and accessibility into these centralized institutions, and maybe there are some cracks starting to show in those institutions. Not to say that we should tear those institutions down, but I do think it's kind of pushed people a little bit to say, hey, what could we maybe do different? What could we actually create that would be different in this world? And yeah, great. So here we go. So now we would see that an exchange like this would effectively become peer-to-peer, and rather than having to do that sort of round relay with a centralized institution, we have a protocol that we're agreeing on that we can all use to exchange. Same with the identification. Again, it's a protocol. It's a peer-to-peer thing. And so this is what blockchain is, and this is why it's so tricky to figure out, is because it has taken millennia of social understanding and norms and security to build up trust, security, accessibility. There have been tremendous breakthroughs in the past couple years, but mainly there's just been a lot more public awareness about it. And so that's what's been really, really exciting. The other aspect that I really, this is one of my favorite headlines. I love This Is Great. It's from a Medium collection. You don't understand Bitcoin because you think money is real. And what this speaks to is that it's not unusual now for me to have my phone and to be able to pay all my bills on this phone. I remember the first time I cashed a check, maybe like 5 or 6 years ago with my phone. I thought, this is crazy. This is totally insane. I just cashed a check like this. It's not inconceivable for money to be totally digital. And so in a way, it's this sort of, this ruthless efficiency. It says, well, if we're making it all digital, can we make it peer-to-peer? I think people are really asking these really great questions in terms of what are ways that we can improve, what are ways that we can make this system in our society more secure, more accessible. And so it's really exciting, I think. It's really, really exciting. Before I go, now I'm going to start going into blockchain primitives, but does anybody have any questions? So I don't want to get feedback before we go on to that. I've sort of been talking a lot. Just curious if people have any questions. Yeah.
Do you have to do all of this stuff on your phone? Because your biggest security breach with phone is the so-called tech support at AT&T or Verizon.
Yeah, great question. So the question is, do we have to do all this on our phone? And the question is no. No, it doesn't have to be done on the phone. I think we're starting to see mobile blockchain wallets now on the phone, but for the most part, it's it's mainly computer-based, but your point about tech support is a really interesting one. And this is what is, I think, preventing a lot of adoption, is that it's very unclear if something goes wrong, who you contact, right? If I delete my private keys, like who do I contact? I think to actually create mass adoption, there's gonna have to be a little bit more support there. You know, you can't just sort of say, hey, I'm sorry, you know, tough luck. You know, say goodbye to your life savings, you just deleted your private key, you know.
Yeah, well, I know a guy who that happened. Somebody went into AT&T and said, I'm Kyle, and
Right.
I lost my phone. And
Yeah.
basically took over his phone.
Right.
And got everything. And they were after his cryptocurrency. And
Yeah. Yeah, SIM swapping is a big thing that's been happening recently in the crypto community, for sure, absolutely.
And you know, I certainly don't depend on those dumbasses at AT&T and Verizon Texas.
There we go. Get it spicy, folks. That's what I like to hear.
Human is still the biggest security.
Yeah, absolutely. So you bring up a really great point, which is that as we are rolling this out into the wild, we're starting to see that there are these sorts of, all these issues that are coming up. And so how can we find these bridges? How can we find ways to responsibly introduce the technology so that we don't have to. That's one of the things I worry about. Some people say, okay, all we need for mass adoption is for people to see that we're not using blockchain. But I kind of feel like that'll just give rise to like the same system that we have right now. So the real question is kind of where do you kind of like how much friction is too much friction, but then how little friction is too little friction. You know, you don't want. One of the reasons that there's been a tremendous amount of data breaches is there's been a lot of convenience sacrificed in exchange for security. So anyways, really interesting point, really interesting conversation that we can talk about later. Let me also just, okay. So, alrighty. So if your eyes glaze over here, you are forgiven because this is a really wordy slide, but we're gonna go from a contextual standpoint, we're gonna start digging in a little bit deeper into the primitive stuff. And this is really important. I would really encourage you, you're like, oh, I'm not technical, I shouldn't look at this, but like I promise, this is good. We're gonna work through this together. We'll get through it together. So, and again, this is a very general statement. So please no one come after me and yell. Well, you can yell at me actually, it's totally fine. But understand that it's generalized. A blockchain network is a state that contains information distributed and secured and without the need of a central authority. It is instead secured by processes executed by members of the network. So when we're talking about we have the centralized institution, we want to replace it with a protocol. What's that protocol? The protocol is this. And we're going to kind of break down a couple of what those terms mean to give you a sense of what we're talking about. So the first question is state. Can any CS kids in here tell me what state is? State.
Is that like when you're talking you access the rollover state or?
Yeah, great. So it's a general term, and the comment here was sort of rollover state. So essentially describing an action that's happening in the world, right? Yeah, exactly. State is a method of describing what is happening in any sort of system. For example, the state of this auditorium that we're in right now. If you were to describe that state, you would describe the number of seats, the number of people, who's on the stage, these sorts of things, right? And the same thing happens over in the digital world. We have in our centralized institution, the state is a ledger that is, the state is, I'm seeing it, yes, great. I was worried I was gonna turn it off, but okay, here's from, to, amount, Bob, Alice, number of, this ledger. I'm sure a lot of you guys have seen this, right? We're talking about distributed ledgers, right? This is the state of the network in a very general sense, right? And a centralized institution, they keep the ledger, right? When we're going to that bank in that first example, what that bank is theoretically doing is looking and saying, okay, does this person have this much? Yes. The bank is holding onto this state. Now, in a blockchain network, that state is distributed by everybody. And this is where it gets a little bit complicated or a little bit strange, which is how could everybody have access to the state? Well, the point here is that we all want to be able to see the different balances and the different activity that's happening in the network. And the way that we do that is we set up these accounts, right? So, for example, everybody in this network here, everybody in the auditorium, imagine that we're a part of a network, right? Everybody's going to have an account, and that account is going to have an initial balance. Some people will have some sort of token, some people might not, and that's all going to be held in a ledger. You can kind of imagine everybody in here holding a ledger, right? Now, let's say that I want to send funds to somebody here in the audience. Rather than just describing it to that one person, I'm actually going to broadcast it to the entire network. And what that's going to allow us to do is going to allow everybody in the auditorium to update their ledger. And that way, and then like once we've updated it, we all agree, yep, this is the new state, and then we can move on and we can do like another transaction. And so that's what this network activity is on a blockchain, right? Is that we're essentially just passing around, you're passing around your own transactions, you're passing around transactions of other people. It's actually called a gossip method of networking. You're just talking to whoever you can about whatever you can and passing around information. Now, a really good observation would be that sounds very complicated and that sounds very network intensive, and in fact it is. To do this at scale turns out to be very challenging. A lot of people are saying, Bitcoin's at capacity, Ethereum's at capacity, and it is true that we are trying to up the amount of transactions that are happening. However, I would say the amount of transactions that are happening today, I think it would have been hard to imagine even 5 or 6 years ago based on this system. So could it be better? Absolutely. But in terms of proving a state and proving a concept, I think it's really powerful. Okay, so we have our state describing the system, right? Now, when that state changes, we're going to be doing that only in transactions, like I just said. So I send somebody some cryptocurrency, they send me some cryptocurrency, and then everybody records that in their ledger, and then we change and we update it, and then we block all those transactions that happen in a certain period of time into a block. And that block is going to be, it's essentially the most efficient way to do it in a decentralized public network where you're passing around a block of transactions rather than just one at a time. So rather than passing around one, maybe pass around 100 or 200 at a certain time frame, a certain network heartbeat. And then the last little bit is those blocks, imagine this is block 0, right, or block 1. Each block is cryptographically tied to the other. So you can literally go from state 1 to state 2 to state 3, and you can see all the network activity that happens as you go along the blockchain. And this is why it's called a blockchain, is because you have these blocks. The blocks are describing both the state that is changing, and they're tied to any previous state changes that have happened as well. Okay, so what prevents somebody from publishing a false transaction? What prevents somebody from saying, oh, hey, I've got 50 of these tokens and I want to send them to somebody else? Well, this is where, this is just a block of different transactions in Ethereum, but we'll skip over this guy. We have these actors in the network that are called miners. And miners, we're not going to talk too much about it because it gets a little bit complicated, but essentially miners are acting in sort of a race to solve a cryptographic puzzle for each block that gets added to the blockchain. They are the only ones in the network that can do that, and they have to do it in a way that is computationally intensive, meaning that it requires a lot of processing power, and I'm about to show you like a very exaggerated photograph that shows a mining rig in China. It will show you how much computation power is required. And it has to be verified by everybody on the network as well. So this is you can see this is Bitmain in China. These are all servers that are running to secure the Bitcoin network. And this is probably the largest criticism that's launched against proof-of-work cryptocurrencies, which is that it's very environmentally unfriendly, which is very valid. However, it does provide a trustless way of securing the network. And That's a sort of a phrase that's used a lot, trustless. But when you actually think about it, we are trusting in something. It's just not a centralized institution. It's a protocol that everybody can run and everybody can agree on. And that leads us to kind of the last fundamental, which is the consensus protocol. Now, these are the rules and conditions that require you to come into a public network, for example. They're also, for blockchain, there are also these very basic cryptographic functions that can run on a computer or on a phone sometimes, or they're very they're very powerful. In fact, a lot of these cryptographic conditions in the 90s, the US government actually tried to classify them as weapons, as like tools of terrorism, and said, no, we can't actually allow there to be private-public cryptography in the public because people will become too powerful. Because it is one of the few examples of what's called asymmetric encryption, or asymmetric sort of a power dynamic, where me as an institution, me as an individual, if I have a public key and I encrypt something, you really can't break that encryption no matter what. There's obviously these sorts of caveats for quantum computing, but let's just keep in 2019. And so that gives us a tremendous amount of power to develop these decentralized consensus protocols, because we have these cryptographic tools, enormously powerful, relatively simple to authenticate, very powerful to, it requires an inordinate amount of power. So it's virtually impossible to break. So, let me just take the time. Alrighty, we're doing okay. So just as a quick overview, we have our state right here, which is our accounts and distributed ledger. Our state is updated by our blocks and transactions. Those transactions are validated and secured by miners. However, the entire network is running a consensus protocol, which allows us all to validate and to update the different actions that are happening on the network and allow us to participate in the network. So now we kind of get into the different flavors of blockchain. So those are sort of the basics there. Next we have what can you build on those networks once they've been established. So what a lot of people have talked about is cryptocurrencies. And so cryptocurrencies is essentially, when we talk about tokens, in terms of a network state, those are cryptocurrencies. And for Bitcoin and Ethereum, those are the native tokens for that network. So if you imagine it kind of like the base token. Now you can also build other tokens on that network, and those are sort of what people talk about when they talk about tokenization. You'll probably hear people talk about today. That's kind of like once you have this really solid foundation of consensus and distributed technology, you can then start to build tokens and tokenize real-world assets. This has been something that people have been working on for a while, and all kinds of problems that arise there, but also really exciting opportunities as well. One of the things is that so I described that system and everyone says, oh, that sounds very idealistic. But in fact, what's very interesting about the system is that it is actually a very brutal economic game. It's assuming that everybody in the network does not trust each other, is actively trying to deceive the other person. And so the level of security is actually quite high, because trying to minimize the amount of implicit trust, for example, trust that's in like a centralized bank, that is sort of the ideal. We kind of don't want that to reside anywhere. So some people describe it as trustless, but it's actually investing trust into these computational methods that we just discussed that make up the consensus protocol, and then providing rewards for those who secure it. So that's why you hear about people who were running, that Bitcoin mining rig, for example, is, these become very profitable over time. It also leads to, issues of its own, but That's sort of the fundamental thing, is that I know it sounds idealistic, but it's actually this very cruel economic reality. The last thing that people talk about in terms of these public networks is something called programmable economies. So, a lot of people, a phrase right now is decentralized finance or programmable money. And the idea here is that on certain networks, you can establish smart contracts, which are self-executing autonomous programs. My favorite example of a smart contract is a vending machine, just like a vending machine that you would find out in a lobby of a building, where you put in money, you punch in a code, and then out comes out like a candy bar or something. Like, that is actually Nick Szabos who developed this concept of a smart contract. That's the example that he used in his paper. It's very, very simple. So if you can do that in a trustless way and with sort of extensive logic that builds on itself, you can then start to chain together these different processes and hopefully sort of compound a lot of the power that you sort of get from that base layer of security. Last thing, and then we'll go to questions, which is permissionless versus permissioned networks. So what I was describing at the top was a permissionless network. And what that means is that anybody, if you are running the consensus protocol, which is typically a piece of software that you download and you run, if you're running that, you can join the network. You can participate in the network. And so these are considered to be highly decentralized in the sense that anyone can join. Now, for the decentralized system to work, that ledger, everybody needs to see everything on that ledger, which is sort of a radical transparency of sorts. So for a lot of businesses, a lot of companies, that's not desirable. And so they have, there's been a movement to create sort of permissioned blockchain networks. Now, these are over here on the centralized system, and this would be sort of an example would be like a consortium of businesses, say in a shipping company, and they're doing business together, and they trust each other enough. They mainly just want to implement a protocol that will sort of allow for an easier way to do business together. So for example, if you're a shipping company and you're going through all these different ports of entry and you have all this paperwork, if you can create a digital protocol that can do those operations efficiently and digitally, that's a way of doing it. However, these permission networks are, I think, is what gives blockchain a bad rap in a lot of ways in these sorts of corporate circles, because it looks a lot just like a distributed database. It's not entirely sure, the innovation there, it's a little bit unstated. So what a lot of the big push right now is for companies to leverage public mainnet, distributed crypto systems in their private dealings, and they can do that through different really interesting, innovative techniques. Some of you, I mentioned earlier, zero knowledge proofs. This is a way of sort of being able to do business out in the open, but also obfuscate the actual processing that's happening behind the scenes. And so this is really important. You'll hear kind of people talk about permissionless versus permissioned, and really what we want to do as a community is really start pushing people towards understanding that the real power of blockchain is a network effect. We want a larger public commons to be able to operate in. If people need to have their enclaves that they come in and out of, that's good and that's understandable, but ultimately it's very important to keep things as decentralized as possible to fulfill what I think some people see as the ideals of blockchain. So I think we'll stop there in terms of blockchain basics. And I'll take some questions for maybe about 10 minutes. Started a little bit late, or just a few minutes. Any questions? Yes, sir, in the red.
So when you're talking about permissions,
Oh, I think there's a microphone. One second.
I can project my voice. Okay. Okay. So when you're talking about permissioned and permissionless networks, are there ways of running basically kind of a permissioned like application layer on top of a permissionless network, maybe leveraging the strengths of both?
Yeah, that's a great question. Yeah, so there are different ways of doing that. There are bridges that can be built from like a private network into a public network, where, let's say, for example, you're an actor on the public network, you want to do, and there are a couple other people, you can lock up tokens on this network and almost create a mirror image on your private network, do operations in here, come back in and unlock those tokens kind of once it's all said and done. And so there are ways of leveraging like that. There are a bunch of different issues in terms of privacy and in terms of, particularly when it comes to commercial interests. Transparency is something that's very tricky to deal with. But yeah, there are definitely these different ways in which people can split the difference between running an entirely permissioned network and a permissionless one, and being able to help leverage the public aspects as well. Yeah, thank you.
So following up on the question, right?
I think there's a microphone coming.
So following up on that question, so one of the feedbacks I was hearing that a lot of the banks or big institutions were interested in blockchain, and then they talked to folks about, how can they leverage it, and they figured out that having a distributed ledger is sufficient for what they're looking for. So what's your counter answer to that point?
Sorry, what's the point?
Yes, the point was that a lot of what I heard, the feedback was that a lot of the big companies wanted to leverage, they were interested in knowing about blockchain, right? And then when they presented the use case, they figured out that, hey, something like a distributed ledger is sufficient. That's why they went for a permission kind of system, right? So
Right.
what's your counter argument to that?
Yeah. So without knowing, the sort of the specifics, but sort of generally speaking, a permissioned network is usually just sort of doing more efficient work within your company, which is really great. However, if you are doing things that cross the threshold of your own company, like if you are doing multi-party transactions, such as bank settlements at the end of day, or any sort of settlement that crosses the boundary outside of your company, that would be something where you would use a permissionless or a public network. Now, it's really important to stress that blockchain cannot be used for everything, right? And so I think that's a really great point, and one of the things that we try to make really clear as soon as possible, that not every problem has a blockchain solution. And so my sort of the rule of thumb that we use a lot of time is if there's a boundary of trust that's being crossed. For example, if you have your company and you are doing a transaction or business with someone that's outside of that boundary of trust, and it's being done in a frequent enough way and there are enough parties, that would be something where you'd want to consider using blockchain. In terms of a bank or that sort of payment settlement layer. Really good questions. Oh, okay, good. All right, I'm getting the high sign. So thank you all so much for your time and for your attention, and I hope you guys, there's a great line of speakers coming up, and thank you so much for your time. Really appreciate it.